Good morning all. So in last class we have seen what is called a general second degree equation. So the general second degree equation was of the form, so you had in the form ax square plus 2hxy plus by square plus 2gx plus 2y 2fy plus c equal to 0. ഇനി അതിന് നമ്മൾ മൂന്ന് ക്വാണ്ടിറ്റീസ് കണ്ടു. ഡെൽറ്റ എന്താണ്, then we have seen what is d and we have seen what is the value of p. Now using delta, d and p, we have classified the general second degree equation into different types. For delta equal to 0 ആകുമ്പോൾ അത് pair of straight lines ആയിരിക്കും. Again delta equal to 0 and when a is equal to b, h equal to 0, so it will represent a circle. And again if delta is not equal to 0, we will get a proper conic. Okay, and in proper conic തന്നെ delta not equal to 0 ആയിരിക്കണം. where d equal to 0 ആകുമ്പോൾ you will get a parabola. Then when d is greater than 0, it will be an ellipse, and when d is less than 0, it is going to be a hyperbola. അപ്പോൾ നമുക്ക് ഈ മൂന്ന് കേസിലും എങ്ങനെയാണ് we will look at how do we get the respective conditions. Okay, അപ്പോൾ നമ്മൾ കോണിക്കിനെ നമ്മൾ ഡിഫൈൻ ചെയ്ത് ഇങ്ങനെയാണ്. if you are given a fixed point and if you are given a fixed line, so this is the point s of alpha beta, and so s of alpha beta is a fixed point and you are given a fixed line l m. Then by conic, that is the locus of the points such that sp by pm, so it is a set of all points p such that sp by pm is equal to a constant e. e equal to 0 ആകുമ്പോൾ നമുക്ക് e equal to 1 ആകുമ്പോൾ നമുക്ക് കിട്ടുന്നതാണ് പരാബോള. e greater than 1 ആകുമ്പോൾ ഹൈപ്പർബോള ആവും. e less than 1 ആകുമ്പോൾ that will become an ellipse. So these locus of points denote the conics, that is parabola, ellipse and hyperbola. ഇനി നമുക്ക് ഈ കണ്ടീഷനിൽ നിന്ന് we will, so using the definition we will derive those condition. അതായത് നമുക്ക് d equal to 0, d less than 0, d greater than 0 വരുന്ന കണ്ടീഷൻ നമ്മൾ ഈ കോണിക്കിന്റെ ഡെഫിനിഷൻ നിന്ന് നമുക്ക് derive ചെയ്യാം. So we will look into this derivation in today's class. So you are given lm to be the directrix. lm is a directrix and s of alpha beta is the focus. That will be the fixed point and the fixed line. The p of xy is any point on the conic whose eccentricity is e. So p of xy is a point on the conic and the conic is having eccentricity e. So conic can be ellipse, hyperbola or parabola depending on the value of e. Ini we are going to write sp by pm equal to e. Ni lm is the directrix, so that is a line. So let me take the equation of lm to be equal to lx plus my plus n equal to 0. That is a line aanu. So this is going to be the standard equation of a line. So let me take the equation of lm to be lx plus my plus n equal to 0. Now from p I am taking the perpendicular line to lm. So pm is a perpendicular to lm from the point p and we have joined the points s and p. Now by the definition of conic, sp by pm will be equal to e. So squaring on both sides, you will get sp square equal to e square into pm square. Let us now find the distances sp and pm. അപ്പോൾ എസ് പി എന്ന് പറയുന്നത് ബൈ ഡിസ്റ്റൻസ് ഫോർമുല ദറ്റ് വിൽ ബി റൂട്ട് ഓഫ് എക്സ് മൈനസ് ആൽഫ ഹോൾ സ്ക്വയർ പ്ലസ് വൈ മൈനസ് ബീറ്റ ഹോൾ സ്ക്വയർ വരും. സോ സ്ക്വയർ ചെയ്യുമ്പോൾ സ്ക്വയർ റൂട്ട് ക്യാൻസൽ ആവും, equal to e square. Now pm, that will be the distance pm will be lx plus my plus n by root of l square plus m square varum. So upon squaring you will get lx plus my plus n whole square by l square plus m square. Now cross multiply cheya. In cross multiply cheyadinu shesham we are going to write in the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So we will collect the coefficients of x square, xy, y square, xy, then the constant term. Upon cross multiply so I have expanded this. So this is x square minus 2 alpha x plus alpha square plus y square minus 2 beta y beta square into l square plus m square equal to e square into, so expansion of this will be l square x square plus m square y square plus n square plus 2 lm xy plus 2 ln x plus 2 mn y varum. That will be the expansion. ഇനി നമുക്ക് ഈ ഫോമിൽ എഴുതാം. അപ്പം എക്സ് സ്ക്വയറിൻ്റെ കോഎഫിഷ്യൻസ് എൽ സ്ക്വയർ പ്ലസ് എം സ്ക്വയർ മൈനസ് e square l square will come. Then coefficient of y square will be l square plus m square minus e square m square. Then coefficient of xy is going to be minus 2 lm e square xy. Then coefficient of x will be minus 2 alpha l square plus m square plus 2 e square ln. Then coefficient of y is minus 2 beta l square plus m square plus 2 mn e square. Then the constant terms are going to be so we will get alpha square into l square plus m square plus beta square into l square plus m square minus minus e square n square varum. Okay, so now once again rearranging that. So this is going to be the form. This is in the form of a general second degree equation. So this is in the form of a general second degree equation. So let us collect the coefficients. So if this represents a general second degree equation, so here a will be, this will be the value of a, and this will be b, and either h in the value, this is in the form 2h xy. അപ്പോൾ h in the value minus lm e square വരും. അതുപോലെ this is 2g x. അപ്പോൾ g in the value minus alpha l square plus m square plus e square ln വരും. Then g യുടെ value f in the value again this is a term 2fy. അപ്പോൾ f in the value minus beta l square plus m square plus 2mn e square varum. 2 is not there, mn e square, and this is going to be the value of c. So we'll have a, b, h, then g, f and c. And now let us look at the condition d equal to ab minus h square. So we have the value of a, then b, and this is h. So let us find the value of d and look for the cases when d equal to 0, d less than 0 and d greater than 0. So ab minus h square എടുക്കുമ്പോൾ, so this is the value of a, b, and this is h square. So upon taking the product you will get l raised to 4 into 1 minus e square plus l square m square 1 minus e square whole square varum plus m square l square plus m raised to 4 1 minus e square. അപ്പോൾ ഇവിടെ നമുക്ക് okay simplify ചെയ്ത് കഴിയുമ്പം just these two terms will cancel off. L square m square e raised to 4 will cancel off, and here 1 minus e square will be common. അപ്പോൾ എനിക്ക് ബാക്കി വരുന്ന termsനെ I can write as L raised to 4 into 1 minus e square plus m raised to 4 into 1 minus e square, then L square m square into 2 minus 2 e square. But 2 L square m square into 1 minus e square. So that will be 1 minus e square into L raised to 4 plus 2 L square m square plus m raised to 4. So that is L square plus m square whole square. So therefore d will be equal to 1 minus e square into L square plus m square whole square. Now let us look at the three cases. For parabola anengil e has to be 1. So when e is equal to 1, L square plus m square whole square is always positive. Okay, karnam perfect square on it is always positive. And when e is 1, d is going to be 0. And when e is less than 1, obviously e square will be less than 1. So this is going to be positive. So d will be greater than 0. Both are positive. So d is greater than 0. And when you have a hyperbola, e is greater than 1. So e square is greater than 1. So this is negative, the positive one. So therefore d is going to be negative. So that gives the three cases. So we started with sp by pm equal to 0. അപ്പോൾ ഈ കണ്ടീഷനിൽ നിന്ന് നമ്മൾ we took this and we have got the value of d. Now when e equal to 1, e greater than 1 and e less than 1, we have got the respective conditions on d. So d has to be equal to 0, greater than or less than 0, which gives the condition for parabola, ellipse and hyperbola. So that is the condition for conic, which is in the general, in the form of a general second degree equation. ഇനി നമ്മൾ സാധാരണ so next we'll look at what is called canonical forms. അപ്പോൾ നമ്മൾ സാധാരണ conic നമ്മൾ എഴുതുമ്പോൾ നമുക്ക് എന്താ y square equal to 4ax parabola ആണെങ്കിൽ അതുപോലെ x square equal to 4y. ഇനി ellipse ആണെങ്കിൽ x square by a square plus y square by b square equal to 1. Then hyperbola ആണെങ്കിൽ x square by a square minus y square by b square equal to 1. So this is the standard equation of the conics, parabola, ellipse and hyperbola. And you can see that all of them are centered at the origin. Okay. Now നമുക്ക് you will get different conics. Okay, അപ്പോൾ നമ്മൾ ഷിഫ്റ്റ് ചെയ്ത കോണിക്കും കണ്ടു. So if you have x minus h whole square by a square plus y minus k whole square by b square equal to 1. So this is conic which is shifted to, അപ്പോൾ സെയിം കോണിക്കിനെ നമ്മൾ hk എന്ന് പറയുന്ന ഇതിലേക്ക് ഷിഫ്റ്റ് ചെയ്തു. So here the major axis and minor axis that will be parallel to this. Here center is just shifted to hk. Okay, so നമ്മൾ ഇങ്ങനെയുള്ള കോണിക്കാണ് കണ്ടത്. Now we will look at when do we get in the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. അപ്പം here the axis will be parallel to the x-axis or y-axis. നമ്മൾ origin shift ചെയ്യുന്ന കേസിലും നമ്മുടെ axis എന്ന് പറയുന്ന x-axisനോ y-axisനോ parallel ആയിരിക്കും. Now we will look for when do we get a conic in this form. അപ്പോൾ generally നമുക്ക് ഒരു general second degree equation വരുന്നത് I can rotate the axis. So നമ്മൾ conic എടുക്കുമ്പോൾ കോണിക്കിന്റെ ആക്സിസ് ശരിക്കും suppose it can be like this. Okay, അപ്പോൾ instead of the xy axis, so the conic is now having axis as these lines. So these becomes the axis. When you have a rotation of the axis, നമ്മൾ axis actually rotate ചെയ്യുമ്പോഴാണ് നമുക്ക് conic ഇങ്ങനെ ഒരു equation എടുക്കുക. And now by using suitable translations അല്ലെങ്കിൽ suitable axis rotations യൂസ് ചെയ്ത് നമുക്ക് ഈ general conic അതായത് general equation by using suitable transformation you can convert into conic in this form. അപ്പോൾ ഈ standard ഫോമിലുള്ള കോണിക്കിലേക്ക് നമുക്ക് convert ചെയ്യാൻ പറ്റും. So such a conic obtained by using the rotation of axis is called as the canonical form. From the general second degree equation, your conic can be reduced to one of the standard forms. So such a standard form is called as the canonical form. So we are going to look into what is called the canonical form. So നമ്മൾ detail ആയിട്ട് next classൽ നമുക്ക് transformations എങ്ങനെയാണെന്ന് കാണാം. So we'll just define what is called a canonical form in today's class. So the general equation of second degree can be reduced to the standard equation of a conic by suitable transformation of coordinates, and this standard equation is called the canonical equation or the normal canonical form. By using suitable transformation, a general second degree equation can be reduced to conic in standard form. So this standard form is generally called as the canonical form or the normal canonical form. അപ്പം നമ്മൾ normal canonical formula we'll be using these steps. To find the canonical form from the general equation, the following transformations are made successively. We need to remove the term xy. So if you take the equation of an ellipse, so x minus h whole square by a square plus y minus k whole square by b square equal to 1. But this does not have the term xy. So we need to remove the term xy. Then 1 or and again x square by a square plus y square by b square equal to 1 ആണെങ്കിൽ it does not have the term xy in it. അപ്പോൾ എക്സും വൈയും വരുന്ന ടേമും xy വരുന്ന ടേമും നമുക്ക് റിമൂവ് ചെയ്യണം. സോ വൺ ഓർ ബോത്ത് ഓഫ് ദി ടേംസ് ഇൻ xy ആർ റിമൂവ്ഡ്. ഓക്കെ, അപ്പോൾ നമുക്ക് പാരാബോള ആണെങ്കിൽ അത് എക്സിൻ്റെ ടേം ഉണ്ടാവും. സോ you will not be removing that. That depends on your conic. So one or both of the terms in x and y are removed by translation. Then the constant is removed if possible. So here in the case of parabola you do not have a constant. So the constant is removed if possible. So those are the steps we will be doing when you reduce a general second degree equation to canonical form. So we will see those procedures of reduction in the next class.